Welcome to Homework Lib.
Hi, so over here we're going to have a perfectly inelastic collision in which one object that is moving at 5 meters per second towards the north with a mass equal to 4 kilograms is going to hit another object that is going to be moving towards the east with a mass equal to 6 kilograms and a velocity equal to 2 meters per second. Over this, we want to know what is going to be the final velocity of the 6 kilogram object after the perfectly inelastic collision. So over here, since we're going to have a perfectly inelastic collision, we know that both of the objects are going to stick together. So the conservation of momentum in each of the axes is going to look like this. The conservation of momentum on x is going to be equal. It's going to generate the initial momentum of x needs to be equal to the final momentum on x. So the initial momentum of x, we're going to call the first object, it's going to be mass 1, and the second object over here, mass 2. So we're going to get mass 1 times initial velocity on x for this object plus mass 2 times the initial velocity on x for the second object, and this needs to be equal to the final velocity on x, which is going to be final on x times the sum of the masses, m1 plus m2. So to solve for the final velocity on x, this is going to be directly mass 1 times initial velocity on x for the object 1 plus mass 2 times initial velocity on x for object 2 divided by the sum of the masses. In this case, object 1 is going to have a 0 initial velocity on x because the movement is going towards the north, which is on the y-axis, and we're going to end up with this equation over here. Mass 2 was equal to 6 kilograms times the initial velocity of this object, which is 2 meters per second, divided by the sum of the masses of both of the objects, that is 10 kilograms, which gives us a value of 1.2 meters per second directly. We can do the same procedure with the final velocity with the conservation of momentum on the y-axis, so applying the same principles, what we're going to get is that the final velocity on y is equal to the initial mass times initial velocity on y for the first object plus mass 2 times initial velocity on y for the second object divided by mass 1 plus m2. In this case, I skipped the derivation because the equations are essentially the same, but now the object 2 is going to have a 0 velocity on y. It is going to have only velocity on x. So now this guy is going to go to 0, and our equation is going to become mass 1, which is 4 kilograms times 5 meters per second, divided by the total mass of the two objects together, which is 10 kilograms. This is 20 divided by 10 gives us 2 meters per second. So the velocity vector for the both objects that are going to be together is going to have a component on the x direction, positive 1.2 meters per second, on the y-axis, plus 2 meters per second on the y-axis. This is going to be our velocity vector. And the magnitude will be equal to the square root of 1.2 squared plus 2 squared. So the velocity of the object is going to be equal to 2.33 meters per second in magnitude. This is the speed of the object, and this is going to be the velocity vector that we're going to be looking at. And with that, it will be all. Thank you very much, and have a good one.